Okay, so let's have a look at another question from the topic of electromagnetism. We're told to find the max possible acceleration of a calcium ion moving at 500 meters per second in a magnetic field of 55 microteslas. We are told the mass of a calcium ion is about 6.7 times 10 to the minus 26 kilograms, and the charge of a calcium ion is about 3.2 times 10 to the minus 19 coulombs. All right. So first, we need to identify the formula we're going to use here. So we have a formula linking acceleration and a series of these variables. We know that the force due to a magnetic field, a uniform magnetic field, is the charge times the velocity times the magnetic field strength times sine of theta, where theta is the angle between the velocity vector and the magnetic field vector. We also know that force is equal to mass times acceleration. This implies that the acceleration is equal to the charge times the velocity times the field times sine of theta divided by the mass. When we're thinking about the maximum possible acceleration, this usually means that theta is equal to 90, because that would make this sine value 1. That's the largest possible value that it could have. It could only have values that were smaller than that otherwise. So this tells us that the acceleration max is the acceleration when theta is 90, so sine of theta is 1. This is charge times velocity times magnetic field strength over the mass. So we have the charge, which is 3.2 times 10 to the minus 19 coulombs, times the velocity, which is 500 meters a second. These are both in SI units. We're going to be multiplying this by the field. Now we're told the field is 55, these are microteslas, 55, this is mu, microtesla. Now everyone always messes these up, I always mess these up as well, so don't feel bad about this. When we convert this, there's about 1 million microteslas in a Tesla, so this ends up being 5.5 times 10 to the minus 5 Teslas. When you're doing these conversions, by the way, when you're doing the conversions between micro, milli, peta, yotta, gamma, nano, you know, whatever the prefix is of the term, it's always a good idea when you're at home on your own or working to check them, right? Go onto something like Wolfram Alpha, go onto something like some kind of unit converter, and make sure that you're right, because there's so many of them, they're very easy to forget. So this is 5.5 times 10 to the minus 5, and I have checked this. This is all divided by the mass of the calcium ion, which we're told is 6.7 times 10 to the minus 26. So this will tell us the acceleration max is the evaluation of all of this. Let me put this in my calculator. 3.2 times 10 to the minus 19 times 500 times 5.5 times 10 to the minus 5, all divided by 6.7 times 10 to the minus 26. My calculator tells me this is 1.3134 ... times 10 to the 5, and this will be in meters per second squared. And this is the answer that we're after in this case.